Okay, so continuing on with that idea of congruence theorems, congruence shortcuts, the next two we're going to talk about are called angle, side, angle, ASA, and angle, angle, side, AAS. So we're going to use these theorems to prove triangles congruent. The first one, ASA, says if two corresponding angles and the included side of one triangle are congruent to two angles and the included side of a second triangle, then the two triangles are congruent. So what that means is C and F are congruent. A and D are congruent angles. That included side is the side in between those two angles. Okay? So the side in between those two angles is the included side. So angle, side, angle. Angle, I'll write that better. Angle, side, angle. Angle, side, angle. Now, they won't always be, these bottom three, but there's an angle, and there's a side in between them. For angle, angle, side, it's two angles again, but it's a non-included side. So what that means is we've got an angle, and we've got a side. We've got a corresponding angle, a corresponding congruent angle, and a side. So angle, angle, side, two angles and a non-included side are congruent to two angles and the corresponding non-included side of the other triangle. Then they're congruent. So to cover some examples, right now we are just focusing only on angle, side, angle, and angle, angle, side. So when we look at this, we look at GHK and JKH. So there's some things we can assume that we can talk about, but when we look at this, I look at angle G is congruent to angle J, and to name these, G and J are okay to name. Now to name angle H in that triangle on the right, I am going to name it angle JHK, to be specific. Angle JHK is congruent to angle GKH. So that's the angle with the single marking on it, okay? And then our corresponding sides, GH and JK, those are marked as congruent. So we can say, yes, they're congruent by AAS, angle, angle, side. So angle, angle, corresponding side. Angle, angle, corresponding side. Okay? So that's an important thing to know. Now, I'm writing out the angles just to keep this information straight in my head. Okay? In part 2, ABC, DEC. This one, angle B is congruent to angle E. And then I think I'll use angle C for both of these because it's angle C in the left triangle, angle C in the right triangle, the triangle on the right. Okay? And then BC and EC are congruent. They're congruent to each other. So when we look at this, yes, these are congruent, and that's by angle, side, angle. Angle, side, angle. We've got two angles and the side in between those two angles. They're congruent, yes, by angle, side, angle. So it's picking out what we can assume and knowing, what we can assume, what we can't assume with our triangles. For number 3, when we look at number 3, it's JKL and MLK. So this is important. There's a triangle on the left and a triangle on the right. So I'm just going to use green to highlight the triangle on the left, okay? So that's one of them. And I'm going to use blue to highlight the triangle on the right. So that's the other one, okay? So what we can say, angle J, I'm going to go back to red here. Angle J is congruent to angle M. All right? And I can say with that, now this marking is a little confusing, all right? Because does it mean, on the one on the left, does it mean J to N or N to L? What I think is it means JL. But I'll try and be a little more specific when we cover this on practices and quizzes, okay? And that's congruent to MK. Now, the thing we can't assume, and the thing we would need for ASA or AAS, is either of these angles at the bottom, all right? But we don't know that those are necessarily congruent because they're not marked as congruent, okay? Or they aren't vertical, right? So we would say, no, we don't have enough info. Oops. Information. We don't have enough information to prove that those are congruent by ASA or AAS, all right? And then this fourth one, we can look at it, we can say angle S is congruent to angle V in the other triangle. We can say that angle T is congruent to angle W because those are both right angles. And we can obviously say, it's marked, RS is congruent to UV. So we've got a situation here. I think that they're congruent, and it's just remembering that distinction here. We've got two angles and the non-included side, because that side isn't in between them. We've got two angles and the non-included side. So these are congruent, yes, by AAS. Angle, angle, side. Angle, angle, side. Okay? So sometimes it helps to just mark those down to keep those straight in your head, all right? So that's an important thing, understanding whether we have enough information or not. So for the next example, a little more tricky, right? Because I am not giving you the diagram, okay? So in parts 5 and 6 of this example, I think what I'm going to do is I'm going to do 5. I'm going to have you do 6 as kind of your guided practice. So let me just draw LMN, PQR. Is it enough to prove? So we're going to draw the triangles, mark the things that are congruent, and then decide. So I'm going to draw, going all over the place here. LMN, and maybe I go L, M, and N. And I don't know the measures of these angles or anything, but if we're proving this, I'm going to line it up so that L and P, M and Q, and then N and R are kind of in the corresponding positions, right? So the triangles are set up so I can visually see what's good there. So then I mark angle M is congruent to angle Q. So I'm going to put a marking here and a marking here for those angles, to show those angles as congruent. M and Q, okay? Angle N, angle R. I'm going to use a different marking for angle N and angle R. Because what I would do there is if I use the single marking again, that would mean M and N are the same. We don't necessarily know that M and N are the same. So I'm marking that N and R are the same. They have the same congruence marking. And then NL and RP. So NL and then RP are congruent. So when we look at this, do we have enough information to prove that they are congruent? I think we do. So I would say yes. And I want you to take a minute and think about which congruence theorem we talked about that would make them congruent, okay? So I would say yes, and I would say a triangle LMN is congruent to triangle PQR by AAS. Two angles and a non-included side are congruent. So I would say yes, they are congruent by AAS. So number 6, I want you to pause the video. I want you to try number 6 on your own and see if you can draw the triangles, okay? And then use them. So this one, we use LMN and PQR. So I'm going to write that out for you before you do it. triangle LMN, is it congruent to triangle PQR? Question mark. Are they congruent based off of this? So draw them, label the things that are congruent, and determine whether or not they are congruent by AAS or ASA. So I'm going to pause the video and give you a chance to do that. Okay, so for this final example, I drew my triangles. I labeled the congruent corresponding parts, or the congruent parts. I won't say corresponding yet, but when we look at this, angle L and angle R are congruent. LM, PQ. Angle M, angle Q. So if I look at this, it doesn't quite match up. L and R are not corresponding. And if we look at it, it should kind of make sense because we have an angle, a side, and an angle here. Angle, side, angle. And then we have angle, angle, side. Doesn't match up. So the reason I say that L and R are not corresponding, and if we look at our congruent statement that we would make, L and R are not in corresponding spots. So that's why I would say that these triangles are not necessarily congruent, okay? They could be, but this is not enough information given to prove that they are congruent, all right? So the last thing here is, this is a nice little piece for us. If you want to, pause the video and screenshot this. It's a nice reference for later on, all right? Usually, if we're in person, I would make a foldable of this, a graphic organizer to help you keep all of these straight. But we just got to remember, SAS, 2 sides and an included angle, okay? Included angle. SSS, just all 3 sides. Hypotenuse leg is with right triangles only. Angle, side, angle, it is an included side between 2 angles. And then AAS, it's 2 angles and a non-included side. So this is a good reference for reviewing at the end of the unit when we take the quiz, and actually on your practice too. So use your notes on the practice, use your notes on the quizzes, and then when you're prepared, take the checkpoint. So I'll have you guys move on to the next step in the lesson from here.